Your job while you watch this video is to fill out the note sheet I gave you in class. The goal of section 3.1 algebraic expressions is to combine everything we talked about lately. So combining like terms as well as distributive property, putting that all together and using it to simplify algebraic expressions as much as we can. Okay. So first things first, here's the ugly problem I've had on the board for the last few days. Now we're going to add in some vocabulary with it. This is not hard, it's something you already know how to do, but it's just putting a name to those things that we're doing. Alright, so terms. When you have terms in an algebraic expression, those are the parts of an expression that are connected by addition. If you need to pause to get that written down, you sure can. I'm going to talk about terms a little bit. So terms in an expression, they're connected by addition. So up here I see an addition symbol, and I see this and this connected by addition. So those are my first two terms. Here's another term because it's connected by addition to the rest of the expression. Another term, another term, another term, another term. So all in all, this expression has 1, 2, 3, 4, 5, 6, 7 terms. All right, then like terms. So we know what the terms are. So we're still looking at those same 7 terms. We want to find the ones that are like. To be a like term, 2 terms have to have the exact same variable or variables, as in the case of up here. This one has an a and a b, and this one has an a and a b. But those variables also have to be to the same power. So if we look at, let's go with the second term right here, it has, no, that's not the one I want. I want this one right here. This term has an a. Okay, so if we want to find like terms with negative 2a, we'd look for terms that have an a. Alright, so here's one over here. The problem is they don't have the exact same power. They're not the same power. They don't have the same exponent. This one is to the second power. This one doesn't have an exponent, meaning that it's just to the first power. So those are not actually like terms. So I've highlighted 2 of the like terms. We could find 2 other like terms if we so chose. We have 4b. So the variable there is b to the first power. The variable over here is also b to the first power. So these 2 are like terms. That looks like it's the only one. So we have 2 sets of like terms. The ab's and the b's are like terms with each other. Pause if you need more time to write down the definitions of terms and like terms. Alright, so now identify terms and like terms in each expression. So first thing we said about terms is that they're the parts connected by addition. Up here, we have some subtraction. So let's get to the point where it's all addition. We could say that 9x minus 2 is the same as 9x plus negative 2 plus 7 plus negative x. So first we made sure it was all addition. Then the terms are the parts connected by addition. Right? So my terms here are 9x, which is connected by addition to negative 2, which is connected by addition to 7, which is connected to addition by negative x, or we could say negative 1x. All right, so there are my terms. Like terms have the same variable, and the variable is raised to the same power. So let's see if I have any other x's. I do over here. Okay, those are both x to the first power. So my like terms are 9x, and let's just use a plus sign since plus means and. 9x plus negative x. Another set of like terms are my constants, or my numbers with no variable. Negative 2 plus 7. So these 2 are like terms. These 2 are like terms. Move on to the next one. Okay. So first, terms, the parts connected by addition. Right now we got to make sure it is all addition. Z to the second plus 5z. Subtraction we're going to change to adding the opposite, so plus negative 3z squared plus z. Alright, so the terms are the parts connected by addition. First I see z squared, which is connected by addition to 5z. I know I'm going to run out of room here, it's a bad feeling. Alright, which is connected to by addition to negative 3z squared, which is connected to addition or by addition with z. So I have 1, 2, 3, 4 terms in that problem. Like terms are the ones I can combine together. So I'm going to start with z squared. All right? So are there any other terms that have z to the second power? There is right here. So like terms are z squared and negative 3z squared. All right? Is there another set of like terms? I have 5z to the first power. Here's another z to the first power. So instead of saying I have 5 z's and one more z, I could say 6z. So since I can combine them, they're like terms. So I'm going to say like terms are 5z and 1z. Okay, simplifying an algebraic expression. Okay, simplifying just means combining whatever you can, reducing it down to its simplest state. So 3/4 y plus 12. First, I'm going to rewrite it as sum. That means write it as all adding. So 3/4 y. I would like you to write this on your paper as well, plus 12. All right, now we have subtraction. Let's change that to plus negative 1/2 y plus negative 6. Okay, so now it's all adding. Remember when we are adding, it doesn't matter the order that we add numbers in. So 1 plus 2 plus 3 is the same as 2 plus 3 plus 1, which is the same as 3 plus 2 plus 1. So we are going to rewrite this so that the like terms are together. So I have 3/4 y and negative 1/2 y as like terms. So I'm going to say, all right, 3/4 y plus negative 1/2 y. All right, and then I see that I also have 12 and negative 6, which are like terms because they have no variable. Plus 12 plus negative 6. By the way, if a term has no variable, it's called a constant. Okay, so now I'm going to combine these terms. 3/4 plus negative 1/2. Remember, so it's going to be negative. Remember 1/2, if we change that to a common denominator, since we're adding or subtracting, 2 times 2 is 4. So 1/2 is the same as 2/4. So we're going to do 3/4 plus negative 2/4 off to the side. And that gives us 1/4. So we have 1/4 y plus 12 plus negative 6, which is 6. Right? So I combine these two like terms, I combine these two like terms, and that's as far as I can go. Right? So I've simplified it down as far as I can. That is my answer. Feel free to pause if you need more time. Lastly, okay, in this expression, right, I still have to follow order of operations, and when I look at order of operations, it says do groups first, I see that I have a group in this problem. However, when I look inside the group, I see that I can't combine them. I can't combine n's with 1's. Right? 6n plus 4 can't do that. But I can distribute, because outside here I have negative 1/2 times everything in this group, times each thing in this group. So I'm going to take care of that first. I'm going to say, okay, we're going to take negative 1/2 times 6n. And I'm going to take negative 1/2 times 4. All right? So here I took negative 1/2 times everything in that group. Here's where I took it times the 6n. Here's where I took it times the 4. And then I'm going to add 2n at the end. Okay, so now that I've distributed it out, I can just simplify these terms a little bit. All right, 1/2 of 6. 1/2 of 6n would be 3n, and they're negative. Plus 1/2 of 4 would be 2, and they're negative. All right, plus 2n. So now I can see that I have 3 terms. Okay, 3 terms being added. I'm going to use the commutative property, which tells me when I'm adding, numbers can commute, or they can move from one place to another, and it won't change the answer. So I'm going to commute my numbers so that the negative 3n and the 2n are by each other. Since they are like terms, they have the same variable to the same power. Okay, then I'm going to say, oh, I can combine these two. All right, so that's as far far as I can go. If I wanted, I could simplify this even more, but first I'm going to tell you this is beautiful, I will take it. But instead of saying negative 1n, I could just say negative n. And plus and negative is the same as subtract. So you could write your answer this way, or you could write it this way, and it would both be acceptable.